Hello guys, today I'm going to explain you how can we solve this problem, pseudo-palindromic paths in a binary tree. This is from Leetcode's weekly challenge. The problem statement says that we are given a binary tree where each node in this binary tree contains digit from 1 to 9, and we need to find such paths from root to any leaf where the nodes can form a palindrome. Basically, if you see this one 2 3 3, we can form a palindrome like 3 2 3, and here we can also form a palindrome like 1 2 1. So in not the exact order of the path, but we can do a permutation of this and then we can see if it can form. Like for example, here 2 3 1 can never form. Like any permutation of this path 2 3 1 can never form a palindrome. And similarly here you can see 2 1 1 can form a palindrome, but not 2 1 3 1, and also but not 2 and 1. Single node can always form a palindrome, as we know. So let's see how we can solve this by drawing some figures. So this is from example 1. Let's see how can we try to solve this. So one thing is for sure that we need to traverse all the paths here, like all these paths coming from root to leaf, these paths, and then we need to know what all the nodes were lying inside the path. And then what we could have done is try to store all these nodes and then try to do a permutation of the array and see if that one of those permutations are actually palindromic or not. But as you can see, in the worst case, one path can have at max as max as 10 to the power 5 nodes, and having a permutation of these many numbers is going to be very time taking. So how can we optimize this? So the key point here is we can only have a nodes value ranging from 1 to 9. So if we are able to find that how many nodes for what's the count of each node value exists there. So for example, in this case we have 2 having 1 count and 3 having 2 count. So by the nature of palindrome, like palindrome can be something like this, like, and let's say this particular value whether it can be 0 or not. So that means any character which is appearing here or any value which is appearing in these subarray will have to be occurring here as well, then only it can be a palindrome. So that automatically makes it that any value which is here will have to be even number of time for this particular pattern to be a palindromic pattern. And this one can be an empty or a size 1 array. So what we can say is, if a given permutation is a palindrome, we should have on at max one such element whose count is odd, and except that all of the elements occurrence should be even. So if we see this particular example where we have seen 2 3 3, we can always form a palindrome by putting the odd one in the middle and all the even ones on the left and right half of this particular value, the odd value. So for example, here we have 3 odd values, so we can never form, whatever we can try, we can never form a palindrome array or palindromic subsequence, or sorry, palindromic sequence. So yeah, as you can see, none of these, and even you can try all the 3 factorial permutation, that is all the 6 permutations, and you can never see that these can form a palindrome. So what's next? Now we know that the property that each of these value has to be even, like the count of each of these value has to be even, or each of them has only one of them can be odd. So let's see how we can solve it further. Now the problem remains that we need to find such path where the count of all the nodes happens to be even except at most one node. So what we can do is keep a track of all the counts of each element, like each digit, in a auxiliary space of 9 size array, let's say. So what initially this array holds is all these value equals to 0, that is the count of 4, count of 6, count of 8, like all the values from 1 to 9, all its count is initially 0. So whenever we reach a non-leaf node, we are going to simply increase the count of this particular node. So basically what are we going to do here is we are going to increase the size of 2. So basically this will become 1, and then we'll check whether this particular node was a leaf node or not. So if not, we are going to do a pre-order traversal. So we are going to take the leftmost, and then we'll reach 3, and then we'll check whether the value of this node is we are just going to increase the count of this particular node. So this will be changed to 1 as well. Then we'll go one more left, and we'll reach another 3. So we'll increase this one to be 2, and so the value of and then we'll check whether this is a leaf node or not. So yes, this is a leaf node because there is no left and right child for this particular node. So what are we going to do at that moment is we'll check the current status or the current state of our auxiliaries array and see how many such nodes were there whose count are odd. So we see that there is only one element whose count is odd, and this is complying with our rule of finding a palindromic sequence here. So sorry, palindromic permutation here. So we can increase the answer by 1. So we have found one path where this particular path where we can form a permutation of all the nodes lying in this path to be a palindromic. Let's continue the example further. So now that once we have seen a leaf node, what are we going to do? We are going to backtrack from here, because if we are not going to backtrack from here, that means not change the state, then for the further path this count will also remain same. So what shall we do? In that case, once we are backtracking, we should be decreasing the count. That means from this node now we are going to backtrack to this particular node, so we should decrease the count for 3. So the new count for 3 should be 1. Now we are here at this particular node. So next node that we are going to traverse is this one, going on this branch of tree. So we have seen that we have one more node, or at least this is the first node for 1. So we will increase the counter for 1, and this state of the array will become 1 now. So this is the leaf node, and we will check here. We see that there are 3 such nodes whose count is not even, that means odd. So this is not going to give us the valid branch, the valid path. So we are going to backtrack again. So once we backtrack, we are going to decrease the count for this particular node, and also we are going to decrease the count for this particular node, and then we will reach here. So let's decrease the count for 1 and 3. So both of them will become 0. So and we will replace both of these value with 0, and then we'll reach here. Then we'll continue adding the next 2 elements into our auxiliary array, the count of these 2. So these will become 2. So once we'll reach this particular node, the last node of this tree, we will see that now there is only one element whose count is odd, and so we can form another valid sequence here. So this will give us total number of two such paths from root to leaf, where we can form a permutation of all those nodes to be a palindromic. Now that we have seen this example, let's see how we can code this. So let's see how we can code this one. So we are going to keep a global answer equals to 0, and what we need to do is to do a pre-order traversal. So we are going to just instantiate one function for that, and what we need is also a path, as I said, a auxiliary path array. So let's first create this path array here. We need a path array for size of, let's say, 10, so that we can have 1 to 9 there. And we are going to let's first create a pushback. Let's say initially all these values are 0, and then we are going to do pre-order traversal with root and p, and in the end we need to return answer. So yeah, now let's see how can we code this pre-order traversal. So if this is not valid one, that is if it is a null, then we are just going to traverse back from here like return. Otherwise, what are we going to do is we are going to increase the value, increase the count for this particular root, and we will check then if roots left is equals to null, and if root right is also equals to null. That means we have seen a leaf node. Then what are we supposed to do here? We are supposed to traverse the path. We are going to check the count of each digit, that is from 1 to 9, and see how many such digits are there whose count is odd. So let's say, for example, initially this count is 0, and we will check if path of I is odd, then we will increase the counter, and then in the end we'll check if counter is greater than or less than or equals to 1, then only we will increase our global answer. And if this is not the case, then we are going to do in order traversal. So let's see how can we do that. Roots left and the same path, root right and same path. And we also said that we need to backtrack to keep the state of the auxiliary array consistent. Alright, so now we have coded this. Let's see if this works well. Yes, let's check for the other examples. Let's submit and see if it works. Alright, so it's accepted. So yeah, thanks for watching this video, guys. Please hit the like button and subscribe if you like my video.